Question 3 on the practice test. For both polynomial functions below, answer the following questions about their roots. The next question's on the next slide. We'll first start with letter A. So let's go ahead and graph 4x to the fifth power plus 5x squared minus 3x, 3x. And we'll zoom in a little bit. And you're going to notice that it hits the x-axis at three distinct spots, none of which have a minimum or maximum at those spots. So you notice it goes straight through, this goes straight through, as well as this one. So when we're going to first answer this question, talking about the total number of roots, what you have to understand first is you have to know what the degree of the polynomial function is. So your highest exponent is your degree, and that's going to always equal the total number of roots. And so since that's a 5, there should be a total number of roots of 5, and that's because the degree is equal to 5. How many real roots are there? Those are the ones that cross the x-axis. And since it crosses the x-axis 3 times, they're going to be 3 real roots. What are they? So let's go ahead and click those and maybe round if we have to. So in this case here, my real roots are going to be negative 1.23, 0, and 0.535. So we'll write those down, negative 1.23, 0, and 0.535. Are any of the real roots double roots? Remember, double roots they might look like this. They might have a maximum at the x-axis. That would be considered a double root. Or it could have a minimum at the x-axis. That would be considered a double root. Neither of these are double roots because they go straight through the x-axis. So since that's the case here, since they go through the x-axis, something like that, where it doesn't have a minimum or maximum at that point, they're not double roots. So this is not going to have one. So how many complex roots are there? Those are the leftover ones. Complex roots is, from everybody that I've talked to, are the roots that are the ones that have imaginary numbers in them. So they'll have i's in them. You will not see them on the graph. So what you do is you take your total number of roots and you subtract your real roots, including double roots. So if like you have a double root in there, it's going to count twice. So you take your total roots and you minus your real roots. And since there are 5 total roots and 3 real roots, there's going to be 2 complex roots. Part B is a very similar question, so you might want to try that one on your own. Here's part B. Pause the video if you'd like to try it on your own, and then you can unpause and check my answers. All right, we're going to go over it in 3, 2, 1. So first, we're going to go ahead and graph that like we did before. It's got x to the 6th power minus 3x squared. And on this problem here, it's going to hit the x-axis 3 times. And this one right here at 0 is considered a double root because it has a maximum at 0. These ones are single roots, multiplicity of 1. So I'm going to go ahead and write that out real quick. Just draw a quick graph of that so I don't have to go back and forth to Desmos. It's going to hit the x-axis there, going to double root it there, and come back over here. Okay, I know this one's going to be 0. I forgot what the other ones are, so let me go back to the graph. So negative 1.316 and positive 1.316. So those are all your roots. Notice that the degree is 6. So there's going to be 6 total roots, and we can just say the degree is equal to 6 for your reason. How many real roots are there? There are 3. Negative 1.316, 0, and 1.316. Are any of the roots double roots? Yes. The double root here is going to be 0. So it's a yes and a zero. And how many complex roots are there? Well, again, this counts twice. So really there are one, two, three unique real roots, but since that one counts twice, it's basically going to be four roots that you subtract from the degree. So you'll take 6 minus 4, and that's going to give you 2, just like our last one had 2. So there's going to be 2 roots that don't show up on the graph. Those are your complex roots. They have I in them. You won't actually have to solve for that I, but that's how you know how many there are at least.